Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about channelization protocols in which we are going to discuss about FDMA and TDMA. We'll see what actually the meaning of TDMA and FDMA. And now here, before actually going to the lesson, lecturer, I am expecting the student will be able to know about what actually the meaning of channelization and what is the actual meaning of FDMA and what are the details of the process of FDMA and what actually the meaning of TDMA and how do you follow the TDMA process. So this is the outcome what actually we are expecting from the students after completion of the lesson. So let us consider that what actually the meaning of channelization. The initial the slide is shown in the way that channelization technique. So the channelization protocol means dividing the channel into following certain criteria. So that is called as a channelization here. The channel can be shared among the stations with respect to two aspects as far as the slide is concerned. One is with respect to the frequency and the other one is with respect to the time. That is why this particular channelization is classified into two methods. One is called as FDMA, that means frequency division multiple access, and the other one is called as a TDMA, time division multiple access. There are two important characteristics we are actually using to share the channel for this kind of channelization. So that is why this FDMA is meant for the frequency division multiple access. That means suppose you have a channel, and the channel is allowing some kind of a bandwidth. Let us say a channel will have a bandwidth of capacity so that it can accommodate the signals from various stations. Let us say that you have a channel, let us say which is of 100 megahertz. Let us say the channel capacity or bandwidth can be represented in the form of the megahertz. The frequency always expressed in terms of hertz. Let us say there is the complete bandwidth of the channel is 100 megahertz. Just imagine 100 megahertz. So now this particular 100 megahertz can be divided among 5 stations with 20 megahertz to each. That means from first megahertz to 20th megahertz, the station 1 is occupied, and 21st megahertz to 40 megahertz, the second station is allowed, and 41 megahertz to the 60 megahertz. So the third station is actually allowed to. Like that, all the 100 megahertz bandwidth is divided between 5 stations, allowing every station to use a fixed bandwidth of frequency. Here, important point here is the 1 to 20 megahertz frequency will not match the frequency that is between 21 to 40. So even though you put some data, even though all information is traveling in this, but because of the frequency variation, so no two channel information will be colliding with each other because their frequency is different, their signal is different. So that is the main the point we have to understand here, why the frequency is considered here, because for every signal the frequency is one of the important characteristic. Based on that you can able to express about the communication, and you can able to put the data on the actual the designated frequency so that the data can be transmitted from one station to another station. So now if you see the point of the frequency division multiple access, in this, a channel access method used in computer networks, especially in wireless communication, this is preferable. Now in this particular FDMA, the available bandwidth is divided into smaller non-overlapping. That is a very important point. Non-overlapping means even though you talk about 1 to megahertz and 21 to 40 megahertz, they will not overlap because their frequency is different. so they will not overlap. That is the meaning of non-overlapping frequency bands, and each user is assigned a dedicated band. That means, let us say first user is allowed, okay, to use this 1 to 20 megahertz, and second user is allowed to use the frequency between 21 megahertz to 40 megahertz. So they will never overlap each other. So they are, even though their frequency is okay, they are in the complete okay, bandwidth, the common bandwidth, but they will not overlap because of the frequency variation. So that is about the importance of why the bandwidth is divided into okay, different bands, and every band is allocated to a station, so that a station can able to use the band of frequency, and it can able to put its data in that. So as shown in the figure. So let us say that there is a frequency on the x-axis, and there is a power on the y-axis, and there is okay, time interval on the z-axis. Let us say it is a three-dimensional figure here. So in this case of FDMA, so you see that this is the total bandwidth. So as I mentioned, that let us say it is 80 megahertz. Let us say, as I have taken in the previous example, the total bandwidth is 80 megahertz. Now the first station, second station, third station, fourth station, and all the four stations are actually taken into consideration a respective bandwidth with a specified predetermined frequency value, and with that frequency value only the station is allowed to put its data in the actual channel. So that is why this particular figure is saying that there is a frequency which is playing a very important role, in which the total bandwidth is based on the frequency. It is divided into fixed number of slots, and every station will be allowed to use the band of frequency for its transmission. So that is why frequency division multiple axis is a very important factor. In this, the frequency is playing a very important role. So here the stations are allowed allowed to transmit the data simultaneously. So here there is no even station 1, 2, 3, 4, even though they all put the data in the bandwidth, but because of the frequency variation or non-overlapping frequencies are there, so there is no point of saying that so there is a collision that takes place here, because even though they are interfering, but they will not have any kind of they will not give any kind of a problem, because the frequency is playing a very important role in this. So that is why it is a very important thing. So what are the key characteristics generally you can identify in this FDMA? So in this FDMA, the its process is very simple, because just you take the total bandwidth, divide that into manageable intervals, so that it is very easy to introduce this. Simplicity is a very important thing you can consider. And simultaneous access, that means multiple users can transmit the data simultaneously without waiting for any other process that is carried out in the channel. So you need not wait for that. Simultaneously, any user can able to access the channel and they can put the data. And key characteristics of FDMA further, if you consider dedicated channels. Why it is called as dedicated? Because the bandwidth that is allocated will not match with any other bandwidth that is existing in the complete division. So that is why it is called as a dedicated channel. The frequency is fixed, and no other frequency will interfere with this allotted frequency, so that it is a dedicated factor you can consider here. So that there is a maximum reliability of the transmission of data in a successful manner here. And the next factor is called as the TDMA process. In this TDMA, time division multiple access, instead of taking into consideration of the characteristic of the frequency, now you focus on the time factor. That means you have some time interval called as channel is there, and the channel is actually divided with some fixed time slots, different stations, so that the station can able to use that channel only the prescribed time interval that is given to the station. So it should not interfere with any other time slot which is not allotted for it. So it has to use the time slot which is allocated for it. So that is why the channel can be shared among the users based on the time slots. That is why it is called as a TDMA. TDMA means for time division multiple access, where multiple users share a single communication channel by dividing the channel into different time slots. And of course, each user gets an exclusive time slot. And in the time slot, the channel is exclusively for the station. No other station will interfere in that, so that the communication is a guarantee communication. But time slot and maintenance of time slot is very important here. So you see the figure. So here, in the frequency FDMA, we have seen about the bandwidths. Now we are talking about the actual, you see on the z-axis, you see the time interval. The total time is divided into time slots. Let us say you have, okay, 6 minutes of time total, okay, channel, you can use it for 6 minutes. But instead of giving the 6 minutes to a single station, better I can divide the 6 minutes time interval between the three stations like this. The first 2 minutes is for the first station, and the other 2 minutes is for the second station, and the third station also will get some 2 minutes of time, so that every station will have some kind of equal time interval slot. But here the second station should not start its job in the first slot, because it is allowed for the first station, so they should not interfere in this, okay, by using different time slots. So it is not allowed here. So now in this case of TDMA, so there are certain things to be followed for a successful transaction. So in that, synchronization should play a very important role. So here the clocks of each and every station should be synchronized. That means they should follow the same kind of clock intervals, or they should use the same clocks, so that there will not be any kind of mismatch of time intervals to be, okay, noticed by the stations. If it is like that, then automatically some station may start early and some station may be delayed with okay, different time intervals that are shown in the clock. So it should not be possible. So that is why we have to strictly follow the synchronization process, so that the time intervals should be followed properly, so that the stations can able to do its job very comfortably. So the key characteristics of TDMA are like this: channel sharing, synchronization, guard times, and dynamic allocation. Here the channel sharing is nothing but because the channel is common, okay, and we are allowing the stations to share it based on time slots. That is why it is called as a channel sharing. And synchronization is another important factor to be verified during the process of okay, transaction. Why? Because the clock should be synchronized, otherwise there may be mismatch of time intervals, so that there is a misunderstanding between the stations, so that they can start their job. So that we have to be very careful about the synchronization aspect, so it should be followed anyhow. And the next point is guard times. So here, instead of okay, continuously allocating the time intervals to the stations, some time slots are kept vacant. Suppose you have already, I mentioned that there is a 6 minutes of total time interval you have. Instead of okay, continuously actually allocating the time slots to the actual stations, you can keep some time slots which are vacant. That means the first station can have, let us imagine that there are okay, 10 minutes of time slot you have totally, and first station is having 2 minutes of time, and give 2 minutes of a vacant slot, which should not be, station will be allocated that 2 minutes of time interval. Again, after 2 minutes of time interval vacant time slot, the next station will have 2 more minutes of time, and again you leave 2 time slots which are actually vacant, like that. These vacant time slots can be called as guard times, so that to avoid the collision, or to avoid the overlapping of information from one station to another station, we are using the concept of guard times. And there is one more thing that is possible in sometimes, that is called dynamic allocation. So it is because of the priority. So suppose I have more data and I want more time interval, then I can be allocated, I can have a time slot which is bigger than the time slot which is allocated to some other okay, stations which are having less data. So naturally I will be preferred to go for a bigger time slot. Then in that case you can call that okay, process as a dynamic allocation of time interval. So these are the various key characteristics of TDMA. So just imagine that simply the actual factors of FDMA and TDMA. Let us say there is actually a floor in a college. There is a floor in a college. Just to understand more simply, just I am showing a small example here. There is a floor in a college, and in the same floor there are rooms. These are the classrooms. Okay, these are the classrooms. Classroom number 1, classroom number 2, classroom number 3. So okay, let us say that every class will have a timetable. Every class will have a timetable. So let us say that the class number 1 is having a timetable in which four courses are actually running. Four courses, and the room is fixed. The students are there, and four courses are running. Okay, the four courses are running in the same room and with different time slots. So the first course may start at 10 o'clock and it may end at 11 o'clock. The second course may commence at 11 o'clock and ends at 12 o'clock. That means here the students are same, but the time slots are actually changing, and based on the time slot the course is starting and the course is ending. So this is the example of TDMA. That means here the multiple access, that means the same room is accessed by different lecturers for teaching four courses. So this is an example of TDMA. That means the target is same, but the lecturers are different, but they are coming to the classroom with different time in different time intervals, and they are able to give their information to the students. So this is the process of TDMA you can refer. And one more thing, that is called the FDMA. So here in this case of FDMA, so in this frequency division, that means so even though we have in the same floor, let us say the floor is the total bandwidth you have. Okay, in the same floor, in the same bandwidth, in the total bandwidth, the room number 1 is fixed room, and 2 is another fixed room, and 3 is another fixed room. This means this total floor is divided into 3 portions. So with fixed identity. So that is why this can be called as the fixed room, can be referred as a frequency, and another room, even though we are noticing that, but that room and its location is different from the first one, which is fixed. So that is why the total floor is divided into different rooms, and every room is having its own fixed kind of location, so that this resembles the bandwidth you can consider. Allocated bandwidth can be considered here in terms of 1, 2, 3. Let us say they are the actual allocated bandwidths to the actual total bandwidth that is there. Even though total bandwidth is taken into consideration, but that bandwidth is divided among the stations, like the room numbers what actually I am showing in the example. So like, it is only a simple scenario to understand better about FDMA and TDMA. And of course that is about today's lesson, and I hope that after completion of this, student is now familiar about what actually the meaning of channelization, and what actually the role of FDMA. What do you mean by FDMA? What are the details of FDMA? And what are the characteristics and what are the basics of FDMA? I think you are clear. And after that, the role of TDMA, and also about the details of TDMA. Thank you.